Now we're going to look at how we can use sum and difference identities to verify and to solve. We've already spent time verifying trig expressions and solving trig equations. We're not going to change any of our steps. We're just going to expand on them. Now when we say we look for a trig identity, now we're going to open it up and say that we don't just look at the Pythagorean identities. Now we look at the Pythagorean identities, our even odd identities, our reciprocal identities, and our sum and difference identities. So on example 1, you've seen this before. This is a cofunction identity, and we looked at in class solving it or verifying it, using a right triangle. Now we're going to look at verifying it using a sum and difference identity. As I pointed out before, you don't necessarily need to memorize all these different identities. You just need to be able to recognize them and find them and use them. So what does that mean to find them? Does that mean looking at your notes? Does that mean going to the book? Does that mean going to a formula sheet? And then that's going to be a question only you can answer because that's going to be different for each person. So on example 1, I notice that this is sine of alpha minus beta. I also know I cannot ever distribute a trig function. So instead I go to my formulas and I say sine of alpha minus beta becomes sine of alpha times cosine of beta minus sine of beta times cosine of alpha. And now I notice that pi over 2 is on my unit circle, so sine of pi over 2, I look on my unit circle, is just 1. I don't know what x is, therefore I can't know what cosine of x is. Same thing with sine of x. On my unit circle, I see that cosine of pi over 2 is 0. Well, 1 times cosine of x is cosine of x. Sine of x times 0 is 0. Leaving me with cosine of x, and my left side and my right side match. I've successfully verified this expression. Example 2 is very similar to example 1. To verify this, again, I notice I cannot distribute a trig function, therefore I cannot distribute cosine in, but I can use a formula to find out what cosine of alpha minus beta is, and it is cosine of alpha times cosine of beta plus sine of alpha times sine of beta. 360 degrees is again a value from my unit circle. Cosine of 360 is 1. And sine of 360 is 0. Multiplying, I get cosine of x plus 0, so I'm left with just cosine of x, and once again I've successfully shown how my left side can be equal to my right side. Looking at one final example, the first two are about verifying, this third one's about finding solutions. I see my solutions are in a given interval, as opposed to finding all or the general solution. I also notice that I'm taking cosine and I'm taking sine of something other than a single variable, so I could use u substitution, but since I realize that this is cosine of alpha plus beta and sine of alpha minus beta, and those are sum and difference identities, I'm going to go ahead and try to use an identity first, and if that doesn't work, as we've talked about before, it can be frustrating, but if things don't work out for us, we just have to go back and try something else. But going ahead and trying to use my identities, it is going to get long to begin with, so I'm going to go ahead and do these two in different colors. So my first one, cosine of alpha plus beta, becomes cosine of alpha times cosine of beta minus sine of alpha times sine of beta. Subtract, and then in the second one doing the same. Sine of alpha times cosine of beta, again just following my sum and difference identity formulas, minus sine of beta times cosine of alpha. And now once again, I have pi, which is a value from my unit circle, so I can find out what each of these are. And I'm left with cosine of x times negative 1 minus sine of x times 0 minus sine of x times negative 1 minus 0 times cosine of x. Going through and doing that multiplication, I get cosine of x minus 0, so just cosine of x in this parentheses, and negative cosine of x, since cosine times negative 1 is negative cosine of x. Subtract, and then in this set, I'm going to get negative sine x and 0, so negative sine x, and this whole thing was equal to 0 in the beginning, so I should have continued to drop down the equals 0. Well, that means negative cosine of x plus sine of x equals 0. So if I think about my different solving methods, oftentimes I look to see if there's anything I can factor. I try isolating the trig function. Sometimes it's helpful to write one trig function in terms of another. And I don't see any of that working for me on this one. So if I try to just isolate one of the trig functions, say I try to isolate sine by adding cosine of x to both sides, I get sine of x equals cosine of x. Well, in the interval from 0 to 2 pi, I know that those two expressions or those two trig functions are equal to one another at a rotation of pi over 4, where they're both radical 2 over 2, and 5 pi over 4, where they're both negative radical 2 over 2. So those will be my two solutions. That's the end of this video. Just to real quick again reiterate the fact that we've done all this before. We are again just bringing in another identity. So make sure that you have some way of being able to reference all the identities, because there are a lot of them and there still will be a couple more. So just make sure you've got that in a nice organized location where you can access those. And bring any questions that you had from this into class with you.